Hey all, this is Derek, and in this video we're going to look at solving systems of linear equations by substitution. And so we're going to end up with, in the last video I mentioned we have graphing, which isn't a very great method because there's just so many limitations on being able to read the graph. Substitution is fine for two variables. It can actually end up kind of messy even in two variables. Gets less fine as you have more variables. But it's still a good one to have up your sleeve. So in the next video, we'll do elimination. That one's going to be the workhorse, but this one's still good to know. So the idea of a substitution is that right now I have two equations with two unknowns, x's and y's, and I want to rewrite those using a substitution as one equation with one unknown. So since x equals negative 5y minus 3, I'm going to take this and plug it right there for x. Because I remember we're looking for the point where these cross, so that x is going to be the same thing in both equations. So if x equals this, I can put it here. And now it's going to give me negative 7, and then times that, because that's my new x. And so there's the substitution. And now I have one equation with one unknown, and we can solve those. So multiplying, we're going to get 35y plus 21 minus 4y equals negative 41. 35 minus 4 would be 31y. Oops. And then I'm going to bring the 21 over. And so that's going to give me minus 62 there. And so y is going to equal negative 2. So that's half of the point, right? Because remember, we're looking for an actual ordered pair. When we graph these things, they're intersecting at some point. So we found the y value, but we still need to find the x value. And so that's where we do a thing called back solving. So I'll take this y, since this equation is already solved for x, I'll plug it into this one. And I get x equals negative 5 times negative 2 minus 3. So that would be 10 minus 3, or 7. So this one would be independent, and my solution would be 7 and negative 2. So then this next example isn't set up quite as nice as this one. So this one had the x already by itself. That was all good. This one does not have that. So I want to look around and kind of figure out which variable is the easiest one to isolate, and then go ahead and do that. To me, I think that x right there looks like the easiest one to get by itself. So I'm going to subtract the 4y on both sides, and then that's going to make this equation be x equals 9 minus 4y. And now that I have that, I can put that right here for that x. Careful not to put it back in the same equation, or it'll come out dependent every time because you're plugging into the same equation. So doing my substitution, we got this, and plus 2, and then there's our new x. Careful with those parentheses. And that's negative 8y equals negative 18, 2 times 9, plus 18, and then that would be minus 8y. And then right here we got minus 18 plus 18, so those drop out. And then if I add this 8y over to get my y's on one side, you can see what's going to happen. Minus 8 plus 8 is 0. And now there's nothing left on this side. So this is going to be one of those dependent systems. And remember, that was in the last video where we got 0 equals 0. So that's where they have infinite solutions, or infinite many solutions, and the system is dependent.